Okay, so in this module, we are to cover address resolution. This is actually just a short module. So for this chapter, we look into the MAC and IP review of MAC address and IP add, and the main focus, the ARP. Um, so again, we have MAC. A computer will be able to have a MAC that's coming from the LAN card or network interface card. Whatever MAC address embedded in the LAN card once installed in a computer, and that will be the MAC address of the computer. Uh, Switch has a MAC. There's that what we call as a base MAC. So that's one thing to take note. Another router. Each interfaces of a router also has a MAC. Like example, this router has a G00, so there is a MAC address for this interface, and so as with G01. In iOS, it's called as a hardware address. Okay, same format, hexadecimal, 48 bits, and there are two parts, the OUI and the vendor is assigned. We've discussed that in the other chapters. And on the other hand, IP is a layer 3 under network layer. It's a logical address. The administrator is the one setting it up, right? It's a component in the operating system. And when a computer sends data, say PC1 sends data to PC2, the data is encapsulated with the source MAC, destination MAC, source IP, and destination IP. Okay? So now we proceed on the ARP. ARP, it stands for Address Resolution Protocol. It's a layer 2 protocol, a data link layer protocol. Okay? So what's the use of the ARP? ARP is used to find the MAC, find the destination MAC address specifically out of a given IP add. Okay? So again, it is used to resolve the IP address to MAC address. And once resolved, it binds the IP address to the MAC address of an end device and place it in its routing table. Okay? Let's consider this diagram as an example. Say H1, okay, H1, this one, will send data to H4. Okay? So again, each computer has an IP add and has a MAC. And we said that again, if a computer, an end device sends data, it needs to encapsulate that with a source IP, source MAC, destination IP, and destination MAC. Okay? So, example, H1 will ping H4. That's our data. It ping a ping request. So, H1, in view of H1, H1 knows its source IP and source MAC because that is its own. Okay? That is its own IP add and MAC address. Definitely, he knows that. The destination IP, H1 also knows that because it is in the ping request, right? If he types ping 192.168.1.7, so H1 knows the destination IP. It has a common sense na, okay, the destination IP is 192.168.1.7. The problem is the MAC. H1 do not know what is the MAC address of H4. So that is why before it sends its ping request, what H1 will do is to send an ARP request. So before the ping ARP muna, it will send an ARP request. ARP request is being sent to all. Okay? H1 will say in the ARP request na, hey, 192.168.1.7, are you there? I need to know your MAC. That's what we have in the ARP request. So all computers here, H2, H3, and H4 will receive that. And then H4 will notice, oh wait, that's my IP address and it's an ARP request. Okay, this is my MAC address. H4 will reply and sends back an ARP reply to H1. Okay, and with that, H1 be able to identify the MAC address of H4. From then, it will now send the ping request. Okay, so I have here a in the packet tracer. Let's try to simulate that. Okay, so there's a simulation part here in the packet tracer for us to see how the data flow is. Okay, also added informations are also displayed in the simulation panel. So like what I did here, there's already an IP address set here. Okay, so we expect that these computers can connect. So let's say we send data from this PC0 going to PC1. If you notice, there are two protocol types here. The ICMP, this is the ping. But if you notice, there's an ARP that appears. That's the ARP. Before the blue one, green one first. Meaning, PC0 kasi do not know what is the MAC address of PC1. So it will first send an ARP request. If we play this one, if you notice, the green one first, this is the ARP request. So PC0 is sending an ARP request to all. So if you notice, it is being broadcast. All computers receive that. It's an X because the IP do not match. Now here, PC1 replies, This is already the ARP reply, and it sends back to PC0. Okay? And then from there, that is only when the ping request is to be sent. Okay? There. So that's the ARP. Okay? Here in the packet tracer, we will be able to also see yung specific the encapsulation, the data encapsulation, okay, in each request. Like the source MAC, destination MAC. If you notice, I click here. This is the first I have to propose this. This is the from switch to PC1. So this is the ARP request, which I said broadcast, right? So this is the MAC address of PC0, and then the destination MAC is all F. Okay, there. And then source IP is PC0, destination IP is PC, PC1. Okay, that's how it is. That's the ARP. Okay, next. Next, okay. Again with the ARP, there's that what we call as the ARP table. If a computer has an ARP table, like if you notice in here, diba, I already there PC0 knows already the ARP request. Okay, PC0 knows already the ARP request. So if I were to send again a packet, say from PC0 to going here, if you notice there's no ARP anymore, because ayan, no ARP already. Diba? The second time I ping, there's no ARP because PC0 knows already the MAC address of PC1. Okay? PC0 knows already the MAC address of PC1. What it does, once it finds the MAC, it is placed in an ARP table. The command for us to view the ARP table is ARP-A. Okay, ARP-A. And if you notice in here, PC0 knows already that there is a 192.168.10.3, that's PC1, and this is its MAC address. Okay, it is saved in the cache. Okay, so if PC0 sends data, it first checks that ARP table. Okay, if it is there in the ARP table, then it will never send the ARP request anymore. It will just refer on the ARP table entry. Okay, that's how it is. If there's no ARP table entry, then that is when an ARP request is sent. Okay. ARP table is saved in the cache memory. Cache. We do know, PC troubleshooting, that cache memory is temporary. So there will be a time that it will be aged out. Okay, that's one thing to take note. The cache time differs depending on the operating system. Again, the command for us to view the ARP table is ARP-A. Also, routers has builds up an ARP table, and the command is show IP ARP. That's for the router. Okay. There is also what we call as ARP. There may be instances that the ARP may be exploited. These can be used by attackers or intruders. It is also discussed in cybersecurity. In ARP, an attacker may flood series of ARP requests. Okay, for example, like in the simulation, this simulation part here, this represents a network monitoring tool. So like if example, you are working as a network engineer, and if you notice there are a series of ARP requests here, and it doesn't end, that is already an attack. It's a form of a denial of service attack. It can slow down your network. It can slow down a device. Okay, we call that as an ARP flooding. There's also another type of ARP we call as an ARP spoofing. Okay, it is discussed in your information security, and if you were to take cybersecurity, it is also discussed in that course. Okay, so this ends this short discussion for chapter 9. So keep safe. Together we learn as one.